I am Dr. Kiranmayi, Area Chair and Assistant Professor, Digital Transformation and Operations, School of Business, Aditya University. In this present lecture, I am going to discuss what is assignment problem and what are the differences between assignment problem and transportation problem and various types of transportation problem and how to solve assignment problem, a case of minimization model using Hungarian method. And coming to assignment problem. So, assignment problem is a special case of linear programming problem, that too it is considered as a special model in transportation problem, and assignment problem deals with allocation of resources to several activities. So, there may be in an organization there may be several resources and several tasks. So, in which each resource is to be assigned to each task. So, in such a case, and whereas only one resource should be assigned to one activity. So, such a kind of problem is termed as assignment problem. For example, there is accounts officer who is having 4 subordinates and 4 tasks, for example. So, his job is to assign one task to each subordinate. Okay, and what is the optimum assignment in such a case? How he can make allocation of each task to each subordinate, right? So, he must assign the task to an efficient subordinate. So, then only it is called as optimum assignment. What is the meaning of efficiency or optimum assignment? That is, if a subordinate is termed as efficient one, if he can do the same task in less time when compared to other people, right? So, if a person can do a job or a task in less time when compared with others, that task is to be assigned to that person. Such kind of assignment is called as optimum assignment. Therefore, how to make such kind of optimum assignment of tasks to the resources or resources to the operations, right? So, that is what we are going to discuss in this present lecture. And coming to the differences between transportation problem and assignment problem. So, transportation problem deals with how transportation of goods from several sources to several destinations, whereas assignment problem deals with allocation of resources to various tasks. So, this is a big difference between transportation problem and assignment problem. And not only that, in case of transportation problem, the matrix can be m by n. That is, there is no constraint that number of rows must be equal to number of columns. But in case of assignment problem, number of rows should be equal to number of columns. That is, the cost matrix must be square matrix. And not only that, in terms of a balanced problem. So, whenever we are solving transportation problem or assignment problem, the first thing we have to look at is whether it is balanced or unbalanced. In case of transportation problem, we understand whether it is balanced or not by calculating total demand and total supply. If these two are going to get equal, then the problem is called as balanced transportation problem. But in case of assignment problem, if number of rows not equal to number of columns, then the assignment problem is termed as unbalanced assignment problem. And another important thing is, in transportation problem, we can give more allocations to each row or each column, but in case of transportation problem, only one assignment can be done in a row or in a column. That is, one person should be given one task or one resource should be assigned to only one task. So, that is how we can understand the difference, or we can distinguish between transportation problem and assignment problem. And coming to the types of assignment problems. So, assignment problems may be a case of maximization model, or assignment problems may be in minimization models. So, if the assignment problem deals with time and cost, then we can consider it as minimum model. If the assignment problem talks about, say for example, sales, so always organization strives to improve or maximize the sales or maximize the profit. Therefore, we should understand if the problem is dealing with maximization of sales or maximizing the profit, then we should understand that assignment problem is a case of maximization model. Always while solving the assignment problem, the problem must be in minimization case only. If the given assignment problem is in maximization model, we have to convert this maximization model assignment problem into minimization model. Another thing we have to understand is, first, while solving the assignment problem, we should understand whether it is balanced or not unbalanced, that is whether number of rows is equal to number of columns or not. If number of rows are not equal to number of columns, we have to make it balanced and then we can solve the assignment problem using Hungarian method. Here is a problem which we have considered to understand how to solve assignment problem using Hungarian method, and here we have a problem in minimization case. Okay, so let me explain how to solve assignment problem which is a minimization case using Hungarian method. So the first step is look at whether it is balanced or unbalanced, that is number of rows are equal to number of columns or not. So here number of rows are 5 and number of columns are also 5. Therefore, after understanding the problem as balanced problem, the first step in assignment problem is find out the row minimum element from each row and subtract that minimum element of each row from the other elements of that particular row. Okay, that is, for example, if we consider first row. Okay, so in the first row, what is the minimum element? 5 is the minimum element. So subtract 5 from all other elements of the same row. Next, this is called row screening. So in the second row, what is the minimum element? It is 3. So subtract 3 from all other elements of that row. Next, for third row, what is the minimum element? 2 is the minimum element. Subtract 2 from all other elements of the same row. So this is how we have to make computations for row wise in the first step. So this is the matrix which we have obtained after performing row minimum element subtractions, right? And after that we have to do the same thing for columns also. So column wise observe which is the minimum element. 0 is a minimum element. So if we subtract 0 from all the elements, same column remains. So likewise, how we have done for a row, the same kind of computations we have to do in case of columns also. Therefore, find out minimum element in each column, subtract that minimum element from other elements of the same column. And after that, now we should start assignments. Okay, so for example, this is the matrix which we have obtained after column subtractions. Now, row wise we have to first start giving assignments. So in the first row, observe how many zeros are there. So in the first row there is only 1 0. So give assignment to that 0. Only 1 0 is there and strike off that row. So that row and look for whether there are any zeros in that row or in that column. No zeros. So strike off that row. And next look at the second row. So second row is also having only 1 0. Assign that and in that column there is another 0. Therefore, strike off that column, right? And then move on to the third row. In third row there are 3 zeros. Therefore, don't make allocation now. Next, move on to the fourth row. Here we have in fourth row only we have 2 zeros. 1 0 is already striked off and there is only 1 0. Give assignment to that 0 and this column is having other zeros. So we have to delete those zeros since already that job was assigned. And then look at fourth row. So, fourth row there is 1 0, but that 1 0 is already got deleted. And coming to the third row, in third row there are 2 zeros. At arbitrary choice, you can give assignment to any 0. I have given allocated this one and strike of other zeros in that. So, now we have made the assignments. So, we have to check whether this assignment is optimum assignment or not. That is, number of assignments must be equal to the order of the matrix, that is 5. The order of the matrix is 5 by 5. Okay. So, let us count the number of assignments 1, 2, 3, 4. So, which is 4, number of 4 is not equal to 5. Therefore, this is not optimum assignment, right? Now, what to do? The next step is, since we have obtained these lines, okay, therefore, we understood that this assignment is not optimum assignment, right? Therefore, we have to move to the next iteration. So, how can we move to the next iteration and how can we find out the cost matrix for the next iteration? Therefore, among the uncovered elements by the minimum number of lines. So, here we have drawn lines after the assignment, okay. So, the elements which are not covered by the lines, that is the elements which I am marking here, those are considered as uncovered elements. So, among uncovered elements, observe which is the minimum element. 2 is the minimum element. Therefore, this minimum element is to be added at the lines, at the points where the lines are intersected, and other elements just which are covered by the lines are to be kept as the same, and 2 must be subtracted from all other uncovered elements, or the elements which are not covered by the lines. From those elements 2 must be subtracted and 2 must be added to the intersection points, and all other elements which are covered by the lines should be kept as the same. Then we will obtain this matrix. Again, let us start allocation assignment for this new matrix in this iteration. So, again we will start from the first row. In the first row only we have 1 0. So, give allocation to that 1 0. So, strike off that row and move on to the second row. In the second row also there is only 1 0, and in that column there is other zeros, strike off that line, and in row we have no zeros, right? Next, and in third row we have 2 zeros. Let us leave it for a while, and D row, fourth row also has 2 zeros. And coming to fifth row, in fifth row there is only 1 0, make assignment and strike off that column since it has 0, right? And next, so move on to fourth row. So, now in fourth row we have only 1 0, allocate that 0, strike off that column. And in third row now we have only 1 0, make assignment of this 1 0. Okay. So, now let us understand whether this assignment is optimum assignment or not. So, that is number of assignments must be equal to, or that is order of the matrix, right. So, how many assignments we have made here? 1, 2, 3, 4, 5. Therefore, 4 assignments have been done. Therefore, the solution is the assignment which we have done is optimum assignment. And now, so what is the total minimum time? So, here we have to write the person task. So, now we have assigned A for resource A, second task is assigned, for B 1, for C 5th, for D 3rd, and for E it is 4th. Okay, and we have to find the total minimum time of this assignment, that we can find out right from the original problem matrix. Okay, so what is the time taken if A is given task 2? Okay, that is, if A is given task 2, he takes 5 minutes of time. So, for A it is going to be 5. B 1. So, for B, if B is given task 1, he takes 3 minutes of time. If C is given 5th job and he takes 2 minutes of time. D is assigned 3rd job and he takes 9, and for E it is 4. Make the total, that is 5 plus 3 8 10 19 23 hours. Time in hours if we consider it as. Therefore, total minimum time of this optimum assignment is going to be 23 hours. So, this is how we can solve the assignment problem using Hungarian method, which is a case of minimization model. By the end of this lecture, we have understood what is assignment problem, how assignment problem is different from that of transportation problem, and what are the various types of assignment problem, and also how to solve assignment problem using Hungarian method, which is in minimization model. Thank you.